You hit record? Oh, thanks. Is the sound bar bouncing? La 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 la. Okay, good, good. Never hurts to check, you know. So I will post this once I get a chance. I may not get a chance until a little bit later today, but I have written the solution for your mission 1, and I will post it in course content sometime soon. If things go really well, I may have mission 1 graded to turn back to you Friday. I mean, that would be best. Can't promise that just yet because, well, I have many many obligations at the moment. But here's the solution. So let me just say a few words about the solution. So, like, what I've tried to do is, if I have a remark, you could say that in some sense that's not part of the formal solution. That's just a comment. I'm trying to help you understand how I know that that's the answer. So if you've included that in your solution, that's great. But if you didn't, I wouldn't probably take a point off, all right? So like this one, as soon as I look at absolute value of x minus 2 less than or equal to 1, the way I understand that inequality is that it's saying that the distance between the number x and the number 2 is at most 1. And so if I know that, I can go, well, the center's 2, and then plus or minus 1 is what that interval looks like. The other way you could do it is that this inequality unwraps as, minus 1 less than x minus 2 less than 1, and then you can solve for x and get 1 less than or equal to x less than or equal to 3. Again, this remark is not required. I don't really think you need to show work for this problem. You can pretty much just write down answers for problem 1. Okay, I mean that's what I. Now the interval notation is kind of maybe the thing you're more getting used to here. I don't know. What happened to you in your mathematical life before you got here? You may be from a healthy home or from a broken home. I don't know what your mathematical home life was before you came here. Like, I have no idea. So some of you may be orphans. I mean, I don't know. I know that my friend who teaches math always tells the students in calculus that they've been cheated. And he proceeds to give them a laundry list of everything he was taught in high school that they have not been taught, and how they should demand a refund. So I don't know, I kind of like that. But he did grow up in Connecticut like 40 years ago, so Okay, so anyway, any questions about this? Is there a particular problem you'd like me to talk about that you had trouble with? We could do that now. No? All right. In that case, I'll put this away and we can talk about mission 2. How about that? Sound good? I'll eventually figure out how to put this away. Actually, let me get mission 2 handy for myself so I can look at those problems. I mean, I have a printout of it, but now I will say this: mission 1, like some of the space in the problems, I don't think it was enough to show work if your handwriting is big, and I'm sorry about that. That's not my intention. I do expect you to work on the test with the problem statements, like not on separate paper. So I'll try to be careful on the test to make sure that there is a stupid amount of white space. So I would just ask you to not panic if you see a lot of white space. That doesn't necessarily mean you need to fill all of it, all right? So I will err on the side of killing trees when I make the quiz and the test, all right? So this homework was a little bit cramped. I'll try to do better on that in future homeworks. At the possibility of hurting your printing budget, I hope that's okay. You're like, printing budget is a small concern. You should see the textbook I was forced to buy for another course, right? Yes. So, I mean, there are math books that I would spend $200 on, but your textbook is not one of them. let's see here. So where were we? Pre-calculus algebra, right? And if I can, so anyone in here that's particularly vexing to you at the moment? 12G. 12G. All right. Okay. Let me look at something similar but different. So here we're faced with a quartic that's a fourth order. Let me make it bigger. X to the fourth minus 10x squared plus 9. So, I don't know. Let's make it x to the fourth minus 6x squared plus 7. That should do the trick. And instead of solving greater than 0, let's do less than 0 just to keep it different. But anyway, if we can solve this one, we should be able to solve that one. So the key first thing we need to do is to understand how to completely factor that quartic. So how should we do that? You think of this as what? Like, if you don't see it already, maybe I have to make a substitution. Say something like, y equals to x squared. Then we've got what? Y squared minus 6y plus 7, right? Can you factor y squared minus 6y plus 7? Oh, no. Eventually, I will learn. Now, the good news is you don't have to make up the test, right? So this is less of a danger to you, right? Making the problem not have the pattern you want. Like, you are free of that obligation, aren't you? Think about it, right? Wouldn't that be horrible if you got to a test and like the instructions are at the top where write the test and then solve it? My brother once had a test when he was in school. He got to the paper and at the top it just is a single sentence. It says, develop chapter 3. Can you imagine that? I mean, you have to like, what happened in chapter 3? Explain, like write the theorems, give the proofs, provide examples, write the definitions, Tell the story in your own words. Wouldn't that be fun? See, yeah.
This actually happened in my high school.
Oh, yeah?
This math teacher, I wasn't in that class, but he told me about it. The math teacher, I think he was looking after a kindergarten class at that point, and the teacher asked him, like, oh, it's 2 plus 2. He just yelled out, tomato.
Tomato?
He's one of them crazy ones.
Huh. I don't think that's right. No, I've been I've been a professor for a while, so I've been on the other side of this, right? How does a test like that got given to a student, right? I'll tell you how that happens. That happens as a bet between professors. Like, Bill's really good. Oh, really? Prove it. And he's like, fine. Next test, I'll just write develop chapter 3. He'll recite it verbatim. You watch. And that's how that test happens, I'm pretty sure. Something like that. I've also written very hard tests out of spite. I once had a student tell me, oh, I don't have to study for this test because you have to write the test for everybody, and so you can't make it that hard just for me because you can't write me a different test than all the other students.
That's a big lie right there.
As soon as he said that very moment, I decided to devote the rest of my day to writing his test. And then I gave him a different test. And he was very, very angry. But it was for a good cause. Sorry, anyway, I'll digress. I'll stop digressing. Y minus 1 times y minus 6, right? But of course, this is really what? This is really x squared minus 1, x squared minus 6 less than 0. And I think, like, this step right here, optional, okay? I mean, I think that if you can see what you're doing, like a lot of people can just go directly from here to here, like that's totally reasonable. That's what I usually do. But if people are having trouble seeing it, I'll include the substitution, you know? So it depends on your audience. And then what can I do? I got difference of squares, right? So this x minus 1, x plus 1, x minus the square root of 6, x plus the square root of 6, less than 0. Draw the number line. And what are my critical numbers? Like plus or minus root 6, plus or minus 1. Root 6 is like 2 point something or other. So that's... Did I tell you guys about the trick for figuring out the signs? That if the only time we flip from plus to minus in the number line is when we have a factor appearing in the expression which is raised to an odd power? Have I told you this yet? So, fun fact. Aww. So sad. Fun fact. The sign in number line only changes for algebraic critical numbers which appear as odd power factors. So what I'm trying to say is like a 1 over x minus whatever number, 3 to the 5th power, it's going to swap. If I go, if I'm at 3, it's going to change from minus minus to plus plus or something like that. Whereas if I had 1 over x minus 3 to an even power, like 402, then what's going to happen at minus 3, rather 3, is it's just going to stay whatever sign it was as you transition across that critical point. The only way we can flip signs at a critical point is if when we completely factor the rational expression, the corresponding factor has an odd power. If you go back and look at all of our examples, you'll see this pattern. So that's good news because that means that there's going to be a sign flip at every single one of our algebraic critical numbers here, plus or minus root 6 and plus or minus 1, because these are all to the 1st power, right, which is odd. And so what that means is you can plug in a number anywhere in here and then go from there. Like one test point will get you started, and then you can just populate the rest of the number line using this rule. What's the easiest number to plug in? 1. Well, 1 is the one thing we can't do. Well, 1 is one of 4 things we can't use. 2? Okay, sure. 2. But you guys are working so hard. Why? 2. I mean, that's a lot of work. Find 2. So 4 minus 1, 3. 4 minus 6, negative 2. So it is negative at 2. So that single test point, then I can generate the rest. Pluses over here, pluses over here, minuses And then pluses over here. It's not on your test, but you know we could graph the polynomial with this if we wanted to, because we know when it's above and below the x-axis. But anyway, I think we talk about that later in the course, so let me leave that for then. So what's the answer to this question then? Less than 0, what's our solution? Minus root 6 to minus 1 unioned with 1 to root 6, right? There you go. So do you see how to do this problem then, like G? You want to factor it completely. Now, does it have to work out like this? If you have a quartic, what else is possible? Think about this. Like, how can a quartic factor? What are the choices? It could be like this, right? It could factor into a pair of quadratic factors, which each factor, right? The other possibility is you could have a quartic where you had one of the factors being irreducible, being prime, so it doesn't factor, and then the other one factors, right? And then the other possibility is that you have like an irreducible and you have a repeated root, or you could have both repeated roots, which are the same, or you could have both repeated roots, which are different. I mean, these are possibilities. There's a lot of different ways that a quartic could factor, right? So there are other patterns that are possible. I'm not sure that this is the same pattern as in this problem, but I think it might be. Oops. I made this too much like your homework problem. My apologies. You're like, no need to apologize, right? I could say it's too late to apologize, but it's kind of dated. The reference is starting to lose its. It still works? Okay. When I teach topology, my whole goal is to work in it's too late to topologize as a joke. It takes some work, but it can be done. I'm glad to see you guys are still aware of this song. That means that if you were to ever take topology with me, and I was to work that joke in, it wouldn't be wasted effort. So, and I'm saying this now, so by the time you take topology, you will have forgotten this comment, and the joke will still be funny. That's good. Can I erase this? Are we good? Oh. Maybe I should be wearing a mask for other reasons. Let's look at this sign chart, sign populating idea with a more complicated example, just so you can appreciate it better. Suppose we have like x to the fourth plus x squared times x squared minus 4x plus 4 divided by x minus 2 times x squared minus 5x plus 6 cubed. And we're going to study that being greater than 0, greater than or equal to 0. That ought to do it. So what's our first order of business with this kind of problem? We need to like factor completely the numerator and the denominator so we can understand carefully what's going on. So the leading factor on the numerator, that one's pretty easy, right? That's just x squared times x squared plus 1, right? And we can't factor x squared plus 1 further because it's an irreducible, it's a prime quadratic, right?
How did you get that?
Oh, I factored x squared out. I'm not done yet. That's just this term. This one is what? If you complete the square on this, what happens? you just get that, right? Because x minus 2 squared is x squared minus 4x plus 4. So like completing the square is just kind of silly there. But anyway, there it is. The denominator, all right, so we've got that x minus 2 out front. And if we factor this, what do we get? Well, let me just do it. When we have, this is the fact, this factors like so, right? Because x minus 2 times x minus 3 is x minus 2x minus 3x, which is minus 5x. Minus 2 times minus 3 is 6, right? We're cubing it, which, how do you, if you have a times b parentheses cubed, you get a cubed, b cubed, right? So we've got x minus 2 cubed here, x minus 3 cubed there. So it's like all x minus 2 all the time, isn't it? So I guess we could clean this up a bit, couldn't we? X squared times x squared plus 1. And who wins? I've got x minus 2 to the 4th power downstairs. So I get 4 minus 2. I think I get a net squared downstairs, right? And then x minus 3 cubed. You got to be careful with this sort of thing in the sense that if you had less downstairs and you canceled it out and you left with like a factor upstairs, you might be led to the incorrect conclusion that you could plug in that number and get 0. But it's not the case, right? If there's division by 0 for that value in the initial expression, then it's out of the running as a solution, giving 0 in the end. So you can like reduce the expression to add points to the domain. This has to do with what are called holes in the graph. We'll talk more about that later. But anyway, there it is. We want to solve that greater than or equal to 0, right? What are my algebraic critical numbers? 0, right? Nothing there, right? We'd need plus or minus I, that's not available. 2, 3. So okay, so what do you guys want to plug in? Okay, I'll allow it. So we get what? We get 1 times 2 divided by minus 1 squared, right? And then minus 2 cubed. So we get plus, 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 minus. We get a negative quantity when we plug in 1. So it's negative in here. All right, so you guys tell me, as we transition across 0 corresponding to this x squared, what's the rule? It's not an odd factor, so we're going to maintain the sign. We stay minus. Like that. As I go from 2 over to here, again, the corresponding factor has an even power, so I stay negative. 3, in contrast, is an odd power, x minus 3 to an odd power. This 3 and that 3. I'm talking about the 3 up here, not the root, okay? That's just an unfortunate duplicity in 3. I don't know. I meant to, shut up. Anyway, that 3, the 3 appearing in the power. So that means we're going to flip from minus to plus, right? And we could check this sign flipping idea by just checking a point, right? Just make sure we're not off. Like, try plugging in minus 1, what happens? minus 1, so this is positive, this is positive, this is minus 1, this is positive, and here you have minus 4 cubed, which is minus 64, so you got plus, 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 minus, you got minuses. But you see this idea of tracking the sign changes according to the powers is, like much faster than plugging in numbers, isn't it? Yeah. But I tell you guys about plugging in numbers to start with, because if I told you the sign flipping idea at the start, you'd all be like, what? Right? So I try to do a little bit at a time, as much as is possible. Oh, what's the answer? I usually like to label things, guys. So I put f of x here, and I'm going to call this thing f of x, all right? That's important because in calculus, we find ourselves analyzing the sign of more than one function at the same time. When you do the derivative test and the second derivative test, you'll write number lines that have the derivative and also the second derivative and even the function at the same time. So you might be looking at number lines for 3 separate functions. If you haven't gotten in the habit of labeling them, then you'll get confused about which one you're looking at. And then you'll need this lose points. And you'll get confused, which is the worst thing. But who cares about points? You're like, we care about points. Some of you care about points. Is 3 in the running? Why not? Because it's what? Yeah, but the critical number could be in the solution if it gives me 0, and we're looking at a less than or equal to or greater than or equal to. But the trouble with 3 is it's just out of the domain of the expression, right? It gives you division by 0. So 3 is excluded, and we just keep going and going, right? So 3 to infinity is your solution. How about, while we're at it, what if we were to solve f of x is less than or equal to 0? What would that give us? What would the solution to less than or equal to 0 be? So it would be minus infinity to 0. Is 0 included or excluded? It's included because it's in the numerator, and we can plug in 0, and it gives us 0. Fine, no problem. So included. That's the difference, numerator versus denominator. And then, unioned with, again, 0 is included, to 2. Is 2 included? Can we plug in 2? Is 2 in the domain of the expression? No, it's not. It's in the denominator, right? The x minus 2 is in the denominator, so we have to exclude the 2. Then what? 3. Is 3 in the... No, 3 is trouble because it's in the denominator again that we get the 0. So we go to 3. Now, you could simplify this, right? You could rewrite this as minus infinity to 2, not included, unioned with 2 comma 3. That's probably the nicest way to write the answer in the other case. No, but I might give a bonus point to the people who simplified it, something like that. All right, other questions? Yeah. 20C. So you guys got the parallelogram stuff all right, huh? No? You do? Some of you do? Oh, yeah, this one. Did you check your answer? Oh. lulled you into a sense of complacency because the previous like 3 links are legitimate. It's just that one that's. Oh. We need better paper. I will find a way to rickroll with paper someday. That answers another one of my questions. You guys do know what a rickroll is. Okay, good.
So, do we have to do 20?
Yeah, 20 is a real question. It's just that that's nonsense. So I think I worked out stuff like this last class, right? Didn't I? So the way to do something like so suppose, this is a circle, find its center and radius. What you do is you complete the square both in x and in y, and then you can see the answer. That's all there is to it. So this is like x plus 11 squared minus 121, y plus 3 squared minus 9. So I've got x plus 11 squared plus y plus 3 squared equals 130. And so from that, I can see that it's a circle, radius square root of 130, centered at minus 11, minus 3. Comparing to the standard form, which is what? So if you just compare these two expressions, you can read off that, the h is minus 11, the k is minus 3, and that the r squared being 130 means that r is the square root of 130. And I think you can do all of these problems using exactly this idea.
On our quiz and test, do you care if we leave our radicals like that, or do you want us to reduce them?
That's fine. You can leave them like that. Oh, 11 squared is 121. So I have to subtract the square of that. And 3 squared is 9, so subtract that. So the basic rule of thumb is that whatever I start with is what I have to go to. So that expression and this expression are identically equal. If you foiled this out, you'd get x squared plus 22x plus 121 minus 121. So the 121's cancel, and we go back to that. And the same is true for this. If I FOIL out y plus 3 squared, I get y squared plus 6y plus 9. But I have minus 9 here, so 9 minus 9 gets me back up to here again. So this is completing the square. Yeah. I think that's probably good for this question. Let me talk about the parallelogram for just a second, because what's the key step in the parallelogram question? What's that? A picture. Yes. Yes. That's exactly it. You need to draw a picture. So I mean, if I were you, I might use graph paper just to make life easier, but I don't have graph paper, so I'll just kind of freehand it. Well, let me just think about this for a second. Given 4 points are the vertices of a parallelogram, find the area. So actually, let me just ignore the given points.
Yeah, but does it matter if we draw it correctly, like graphically, or if we just draw a parallelogram and label the points correctly?
Well,
Do it that way?
I think you can get into trouble
I mean,
if the
if we're trying to, if we're counting the squares and all that, but if we're doing it.
well, yeah, I don't want you to count the squares, but
Yeah.
I mean, what I'm trying to say is, I don't know if you could somehow draw the points, and if you got confused about the relation between the points as they relate to the sides of the parallelogram, like if your picture was so scrambled, if it's not the scale, it's fine. So A is 1, 2, right? Let me just make a very rough picture here. 1, 2. B is 5, 2. C is 3, 6. D is 7, 6. Right? So the thing looks something like this. So what I'm trying to say is, as long as your picture's like that, you should probably make reasonable claims, right? Oh, okay, okay. But how would you figure out the area of that parallelogram? Like, how do we? The formula we use, like, what is that formula? Base times height, right? Because we can take a parallelogram and slice it into two triangles, and we know the area of a triangle is 1/2 base times height. So you're like, no, we know that the area of a parallelogram is base times height, and that's how we derive the area of a triangle is half of it. Fine, be that way, whatever. But the point is, yes, base times height. What is base? I'm just saying, yeah, don't answer for that. I'm just saying, generically speaking, this is the base, right? You're fine. And the height is this whatever this is. Right? Because the basic idea is you could take that and just like slide it over and make a rectangle that's base and height tall, and that would be the same area. There's a name for this principle. It's some Greek. They're dead. They won't know. They've been dead a long time. But anyway, those Greeks, they did a lot of stuff. I'm sure there's also some forgotten Chinese and probably some forgotten Indian who did the same thing, in all likelihood. Posting videos on YouTube always precipitates these kinds of comments. Such and so forth did it in the 4th century in Bangladesh or something. It's like, wonderful. Yeah, I mean, I personally am of the opinion that the ancients knew much more than we gave them credit for. Like, we only have a slice of what has been recorded by them. You know, the things that were built in the ancient world testify to a fairly deep understanding of geometry, and you can't have that without having some amount of algebra and math and trigonometry. So, anyway. That's not on the test. Do you guys have another question here? Do you know how to find the midpoint between 2 points? How do we find the midpoint between 2 points? We do what? Add them and divide by 2, right? What if you had 3 points and you wanted to find your center? How would you do that? Like if I have 3 points, A, B, C, and I want to find the geometric center of A, B, C, how do I do it? Points A, B, C, you know what I do? Add them up and divide by 3. If you have n points, you want to find their geometric center, you know what you do? Add all their coordinates up and divide by n. This can actually be a kind of useful trick if you're working a problem where you have like, you know, like a pyramid or something, and you have the coordinates of the bottom, and you want to find the central point. You can find that central point by adding the coordinates of the base vertices and dividing by 3. It'll give you the center point. You're saying find the midpoint of that, find the midpoint of that, find the midpoint of that, and then do what?
No, just find the midpoint of A and C.
Uh-huh.
And then go the midpoint from that point to B.
So would the, oh, your question is the midpoint, is that actually the center? Maybe. I don't know. So what if I had 0, 10, and I had like -2, 0, and over here I have like, you know, 8, 3. Midpoint of these guys is what? Six 3/2, right? Because 8 plus -2 is 6. And then what's the midpoint of these? 23 over 4, I think. Because like 3 halves plus 10 is 20 halves, plus 3 halves, which is 23 halves, and the half of 23 halves is 23 fourths. So that would be the alleged midpoint according to your find the midpoint and then find the midpoint again. But in contrast, we could try just adding these 3, which would be what, 6? And then, adding minus 2 plus 0 plus 8 is 6, right? And 0 plus 10 plus 3 is 13. Divide by 3. We've got 2 and 13 over 3. And this and that are not the same point. So there is a difference. But that difference might go away if you look at special kinds of triangles. My triangle's scalene, so if it was true for isosceles, it wouldn't. Maybe if I picked an isosceles triangle or something. I don't know. I kind of doubt it's true because the midpoints divides by 2, whereas if you just find the geometric center of 3 points, we're dividing by 3. And it's hard to get from halves to thirds. They're like sort of in different worlds. It's the problem with division. Puts us into different camps. Can't get from one to the other, can't understand each other. What's that? Oh, no. This is just me wasting your time. I'm helping you with some Calculus 3 problem you'll see 2 years from now. Sorry, is there another question about a problem in here? 13A. 13A. So yeah, I seem to have asked you questions about absolute value plotting, and it didn't happen in my examples that I showed you guys in class. I think I showed you guys stuff more complicated than this, right? But if we have absolute value of x less than or equal to 2, what's that mean? How can we understand that in terms of like an inequality without absolute value? Plus or minus, right? We can trade this for minus 2 less than or equal to, so you're saying between plus or minus 2? Is that what you meant? Oh, the equality would be plus or minus, absolutely. But I'm just saying as an inequality, the absolute value of x being less than or equal to 2 is equivalent to x being between minus 2 and 2. In contrast, if we had absolute value of x greater than 2 or equal to 2, that would be equivalent to x less than or equal to minus 2 or x greater than or equal to 2. And so like this one, if I was to plot it, would look like this. Oh man, I was hoping it would just smudge it, but I can use my hand. I'm going to regret this. Anyway, I tried. That's not the answer to your question, but I think you should see how to do it from there, right? Yeah. Other questions? 22, which one? 22B? So this one, when you click, you need to, first of all, you want to look at the electronic one, because then what it does is it brings up, hey, that's A. Oh man. What just happened here? I think my link is wrong. What was the problem? Can you tell me what, I'll fix it here. What was the equations?
1 plus x equals square root of 1 plus x squared.
Uh-huh.
or negative 1 is less than or equal to x, which is less than or equal to 5.
Okay. So one way you can solve something like this is to look at the left-hand side as one graph and look at the right-hand side as another graph. Where they intersect is the solution. So what did you guys just tell me was what? Square, I can't read my own writing. 1 plus root x? And the other one was what? I don't even know how I did that. All right. And I'll zoom out a bit. So definitely we can see here from 0 to, from what? From -1 to 5. And there are two solutions. One happens here, and one happens there. And we can zoom in and find them. And that's how to solve this one. Yeah, I'm sorry. That I don't know how that happened. That you don't if do email me when you find something like that because I can try to fix it. But so that one's I can see that solution, right? Solution 0, right? This. Oh, look at that! If you click on it, it'll even look at that. You see that? I just click on it, and it man, this thing's gonna make us lazy, isn't it? So this is obviously not a test question, right? Because you don't have Desmos on the test. But I want to point out to you that to find numerical solutions to algebraic equations, we have many, many toys to do that. The solution is, 2.315. I think I said 2 decimal places, so 2.32. Anyway, thanks, guys. I'll see you Friday at the quiz, right? Remember, you can bring your page of notes if you want. What's that?